Now I want to show you it's how we kind of use this in solving problems. We take a look at number 5. We can see that we have two angles that are congruent, so therefore it's going to be angle, angle. But what I'm really interested in is how to solve for x. So the most difficult part here is going to be lining up your corresponding parts. So what corresponds to what? Say it.
So 5 corresponds with, no, wait, 6 corresponds with 9.
How do you know that?
Because it's the two angled.
Yeah, it's the included side between my two angles. So notice how we're kind of looking at the parts, looking at their orientation, because we're lining those up. So 6 over 9. So we did the left over the right. So it would equal
5 over x.
5 over x. Now one thing I'm going to recommend, especially when you're using proportions, is to always simplify. So 6 over 9 can be reduced down to what?
2/3.
And now it's a little bit easier to cross multiply. So we get 2x equals 15, and therefore x is 15x. All right, when we look at number 6, this is kind of interesting here. Anytime we have an angle bisector of a triangle, we're cutting this angle in half. The two triangles that are left over become proportional. They're similar. And the way that I always set up these types of problems is I just take these two sides and match them with these two sides. So we get 6 over 4 would equal what? So notice what I did here. 6 over 4.
X. 2x plus 3.
No, x plus 3 over
Over
x. So now how do we solve this? Cross multiply. So I get 6x is equal to 4 times x plus 3. Okay, this is where your Algebra 1 skills have to come in. What are you going to do with the 4? Okay, so we get 4x plus 12. Okay, so we get 2x equals 12. Therefore, x is 6. Yay, that was fun. Alright, I think we're pretty much good here. I think you guys kind of got the point. But I want to make sure we talk about this one here. Good application problem. When dealing with similar triangles, this is actually one of those life skills that some of you guys might never use, but it's a really good way to know how to do difficult things. Perfect example of this would be not necessarily know how tall a building is, but maybe you need to know how tall a tree is. Let's say you're cutting down a tree and it's pretty close to your house. How do you know if that tree is going to be tall enough to fall and hit your house?
ratio with the shadow.
Educated guess. Okay. Well, what we can do is this basically proportions. And if we draw the diagram, it kind of makes sense. We're going to have a guy who is 2 meters tall. So here's our man. He's 2 meters tall. And he's going to cast a shadow that is 6 meters long. And so then we have a triangle. We have a right triangle. Then we have this really tall building. And we don't know how tall the building is, so we'll say that's X. But we do know that the building has a 36-meter shaft. And you guys see how the two triangles are similar? And so they both have the right angle, and they both have the congruent angle down here. Sam?
So would X be 12?
Yes. So we know that these two triangles are going to be similar because it's angle. And then all we have to do is use the ratios of the corresponding sides. And the easiest way to do this is height over shadow is equal to height over shadow. So 2 over 6 is equal to x over 36. So 1/3 equals x over 36. 36, and x is therefore 12